Alright class, in this video we continue our discussion in section 4.4 on the laws of logarithms. We're going to pick it up at the bottom of page 2 of your lecture handout, and what we're going to be doing in this video is expanding some logarithmic expressions. And what expanding a logarithmic expression is you start with a single logarithm like this one here, log base 5 of xy to the 7th power, and we expand it so as to rewrite that single logarithm as a sum and difference of logs. So we're going to go from one logarithm to two or more logarithms, right? Sum and difference of two or more logarithms. And we're going to apply the rules, the laws of logarithms, the product rule, quotient rule, and power rule in expanding these logarithmic expressions. So we begin with log base 5 of xy to the 7th power. So this entire quantity in parentheses is being raised to the 7th power. And so we know by the power rule that that exponent 7 can be brought down in front of the log. And so applying the power rule, we have 7 times log base 5 of xy. Now this inside the parentheses, this xy, that's a product, x times y. And so by the product rule, we can rewrite log of xy as the log of x plus the log of y. And then since we have to multiply, we have to put that quantity in parentheses, right? Log base 5 of x plus log base 5 of y, because that entire sum is being multiplied by 7. And then when we distribute the 7 inside the parentheses, we have 7 times log base 5 of x plus 7 times log base 5 of y. And that's our final answer. So this log base 5 of xy to the 7th is equivalent to this down here, our final answer. At the top of page 3, we have log base 4 of x times the square root of y. So we want to expand that as much as possible, right? Write it as a sum and difference of logs. Well, this is a product inside the parentheses. So this is equal to the log of the first factor plus the log of the second factor by the product rule. So this is equal to log base 4 of x plus log base 4 of square root of y, and you know the square root of y is equivalent to y to the 1/2 power. So we replace square root of y with y to the 1/2 power, and then by the power rule, that 1/2, that exponent 1/2 on the variable y, can be brought in front of the log base 4, and so this is equal to log base 4 of x plus 1/2 times log base 4 of y. So this up here, log base 4 of x times the square root of y, is equivalent to this sum down here. This is our final answer. Next we have log base 3 of 4x over y. This is a quotient, so we can apply the quotient rule. The quotient rule says this is equal to log base 3 of the numerator, 4x, minus log base 3 of the denominator, y. And now this 4x, that's a product, that's 4 times x. So using the product rule, we can write that as log base 3 of 4 plus log base 3 of x. And then we subtract log base 3 of y. So the log of this quotient up here is equivalent to this sum and difference of logs down here. Next, we have something a little bit more complicated. We've got to expand log base 2 of the quotient x to the 6th power divided by 7t squared. So the first thing we want to do is apply the quotient rule, split up that quotient. And so the quotient rule says this is equal to log base 2 of the numerator minus log base 2 of the denominator. Now, this first term here, log base 2 of s to the 6th, that 6 on the variable s can be brought down in front of the logarithm by the power rule. So this first term is equal to 6 times log base 2 of s. And then this in the log base 2 of 7t squared. 7t squared is a product. So in applying the product rule, this is equal to log base 2 of the first factor 7 plus log base 2 of the second factor t squared. Well, this inside parentheses here, log base 2 of t squared, the exponent 2 on the variable t, it can be brought down in front of the log using the power rule. So log base 2 of t squared is equal to 2 times log base 2 of t. Now we distribute the minus sign inside the parentheses, and we have 6 log base 2 of s minus log base 2 of 7 minus 2 times log base 2 of t. So this logarithm up here, log base 2 of s to the 6 over 7t squared, is equal to this down here in expanded form. This is our final answer. In the next example, we have log base 3 of square root of 3x to the 9th, all divided by y. So again, we have a quotient, so we want to break up that quotient. And so this is equal to the log of the numerator minus the log of the denominator. So we have log base 3 of square root of 3x to the 9th minus log base 3 of y. Now, you know, whenever you take the square root of something, right, that's the same as raising it to the 1/2 power, okay? And so square root of 3x to the 9th is the same as 3x, or yeah, square root of 3x to the 9th is the same as 3x to the 9th raised to the 1/2 power. And now you know by the power rule, this exponent 1/2 can be brought out in front of the log. And so when we do that, we have 1/2 times the log base 3 of 3x to the 9th. And now 3x to the 9th, or 3 times, I should say 3 times x to the 9th, that is a product. And so we can split this log up using the product rule. Right? Log of base 3 of 3 times x to the 9th is equal to log base 3 of 3 plus log base 3 of x to the 9th. Well, log base 3 of 3 in parentheses here is equal to 1, right? Because 3 to the first is equal to 3. So log base 3 of 3 is equal to 1. And then log base 3 of x to the 9th, this exponent 9 can be brought down in front of the log, and we have 9 times log base 3 of x. So the last step is then to distribute the 1/2 inside the parentheses, right? We got the sum of 2 terms, so each term gets multiplied by 1/2. 1/2 times 1 is 1/2, and 1/2 times 9 times log base 3 of x is 9/2 times log base 3 of x. And then lastly, we have the minus log base 3 of y. So this logarithm up here, log base 3 of what's in parentheses, when we expand it, is equal to this down here. This is the final answer down here.